Okay, this is the M1 paper from January 2024. This is question number 4, and this is a forces diagram question. I'm going to do this by using a vector method, triangle of forces. There are other methods that you can do, but I want to just practice showing one of these for my students. So, we have a situation where all that information is on the diagram. I can read through it, but you've basically got P and Q acting on the particle. You know that Q is 5√3. We don't know what P is, that's given by X. We've got the angles of 150 and 30 degrees there. And it says the resultant of P and Q has a magnitude of root 129. Can we find the value of X? Can we find the angle between Q and the resultant? Yeah, so what I've done to start off with is I've already drawn out the diagram again. And as I say, I'm going to do this as a method called triangular forces. So what I'm going to do is I'm just going to pick up this force and I'm going to put it over there. Let's move Q to say that we've got Q going here. So why would I do that? Because if I do that, then what I can actually say is that the resultant force is going to be this force here. That's the resultant force there. If I think about this as Q followed by P. Okay, so Q followed by P would give me my resultant force there. And obviously I know that the magnitude of that is equal to root 129. Well, if I get rid of that angle there just for the time being, what I've now got here is a triangle where I've got two sides, either side of the angle, 30, and the opposite side there, root 129. Well, that looks very much to me like the setup for a cosine rule question. So if it was a cosine rule question, change my colour so I can show you what I'm doing, this would be angle A, this would be little a, B and C, it doesn't matter which way around that we do them, but if I do have that scenario, I can then say A squared is equal to B squared plus C squared minus 2BC cos A, and if I substitute everything in there, the only thing I don't know is X. So A squared is root 129 squared is equal to X squared plus 5√3 squared minus 2, lots of X, lots of 5√3 cos 30. You might be panicking thinking, oh, this doesn't look very nice. Let's just keep going with it though, let's be resilient. That's going to be 129. That's going to be X squared. 5√3 squared is okay. That works out to be equal to 75. And now here, the fact that cos 30 is root 3 over 2 means that the root 3 and the root 3 will go. Just put it into your calculator and you'll see that what that all comes out to is just minus 15. And the X, of course. But now, looking at that, well, that's a quadratic. So if I tidy it up and make that look like a quadratic that I can factorise maybe, X squared minus 15X minus 54 equals 0. And yeah, that does factorise. That factorises to X minus 18, X plus 3 equals 0. And so just because of the situation within the question, this is going to be X equals 18 or X equals minus 3. But I'm going to discount that one. We're looking at a, from the diagram, X equals 18 is the only sensible answer to take from there. Okay, part B then, part 2, says can we calculate the angle between Q and the resultant. So Q is that force there, the resultant is that force there. So what they're asking me for is that angle there, that obtuse angle there. So when I'm going to do this using the sine rule, if my answer works out to be an acute one, I'll let's do it, and then we'll talk about just being careful about the last part of it. So if I'm doing sine rule, I want two pairs, don't I? So I'm going to have X and that angle, and then I'm also going to have 30 and the root 129. Those will be my two pairings for my sine rule. You should absolutely be able to do this IGCSE work. I'm going to say sine theta over 18 will be equal to sine 30 over root 129. Did I call it theta? Let's call it theta in there, sine theta. So sine theta is just going to be equal to 18 sine 30 over root 129. So work that out on your calculator. Sine theta works out to be 0.7924. Inverse sine of that, well, the calculator is going to give me 52.4, but I know that there is an alternative, 180 minus 52.4, 127.6, and again, from the diagram then, 127.6 is the obtuse angle that I needed. Did they say anything? Yeah. Oh, nearest degree. Okay, so 128 equals 128 degrees. Let's not lose silly marks for not reading questions properly. So yeah, interesting question. You could have done that in a different way, but I wanted to do at least one example on my channel of triangular forces. So that's what I've done there. Hopefully that all makes sense to everybody.